Hi everyone, today's video is on writing linear equations, and what we're going to do first is just talk a little bit about converting English sentences or terms to their math equivalent. So the first box on the top of the screen here I have right off of your note packet, and what I've done is taken an English sentence and converted it to what it would look like as a mathematical equation. Alright, and if we just read the left-hand box there, it says the number 2157 is the difference of the squares of two consecutive even integers divided by the sum between the two consecutive odd integers. Alright, now I intentionally started with a rather big sentence to show you that kind of what we're working towards. Alright, this is not one of the problems we're going to ask you to do in the assignment. We're going to start out really small, but I wanted to show you what you can work towards in converting English sentences to mathematical sentences. Alright, so if I pick apart the parts of this English sentence, I can just take it right along here. The number 2157, that would be this number right here. And let me get my pen back here. There we go. And I say the number 2157. Well, that's where I get that number. That should be a 2 right there. And basically, when I do these, when I try to convert English to math, I kind of go along in the sentence and I cross out what I've used. Alright, so I used that to get this. Alright, and then when I hit that word is, that usually means I put in an equal sign. Alright, so there's my equal sign. Now we come along to a mathematical operation, and the difference, well, back in elementary school, you found out, or you learned, that the difference means subtraction. So difference, here I've got my subtraction, alright? And then I come to of the squares. Well, to square something means to raise it to the second power. So here's the squares, and notice squares is plural, so I have 2 of them, of 2 consecutive even integers. Alright, so we're going to learn very soon about consecutive even integers and consecutive odd integers and consecutive integers, but here are 2 consecutive even integers. And then I come to divided by. Well, that's where I get this bar right here. That means divided by. And it says then by the sum. Well, sum, when you sum something, it means to add them. So there's my addition symbol, between 2 consecutive odd integers. And there are my 2 consecutive odd integers. Again, we're going to talk about that in a little bit. Alright, so even though this is a long English sentence, if you take it by parts, you really can build a mathematical sentence simply by going along in the sentence. Alright, I'm going to take all that. Oops, I don't want to do that. I'm going to try to take all that out of there. I don't think I can without erasing everything. Alright, so there you have it. That's what we're kind of working towards. Now rarely are you guys going to have to convert a problem like this into a mathematical equation like this. That's a pretty big one to do, but I just thought I'd start out with one that is pretty involved, just to show you it can be done. Alright? No, so let's go down to this next box, and this box really, I put it in here because I thought these are some common terms that you're going to have to use in order to convert an English sentence to a mathematical sentence. Alright? So this is a good reference for you when you go to do assignments and such. And after you do more and more and more, they really will sink in. So if you see the term sum or increased by or total, usually that means we are adding things together, alright, or terms together. If you see the word difference, or you see less or less than, and these are the 2 that people really get stuck on, because when you say less, or less than, it means two different things as far as which term goes first. They both mean subtracted, see, subtracted from or taken away from. All of those mean subtracted, but the less and that less than really mean a different order in which you put the terms that you're talking about. And again, we'll do more of those as we go here. All right, the term of or product of usually means multiply. So I'm going to put just the dot down here for multiply. You could put an X, but again, we're turning into more algebraic type people, and X usually means the variable that we're talking about. Quotient or divided by, quotient of or divided by, that one's pretty obvious. That is always division, so I'm going to put a little division symbol there. And here we have not a mathematical operation, but a term that comes up quite a bit. Alright, if I say twice a number, or twice x, or twice of something, that usually means I'm taking it and I'm multiplying it by 2. And I shouldn't say usually, it always means I'm taking something and multiplying it by 2. Another one that I didn't put down here, you could say 3 times of a number. Well, that would be 3x or 3t, etc. Alright, next to a number squared, we already saw that one right up in this example. A number squared means you're going to take some number, x or t or y or maybe even 3 or 4, and you're going to raise it to the second power. Okay? And a number halved, well, if I half a number, then I'm going to multiply it by a half. Alright, so I think that's a good box just to have next to you. Like I said, at least until we do more and more and they start sinking in. And even my 9th graders and 10th graders and 11th graders, you know, when they go to convert sentences to mathematical equations, a lot of times, you know, we have to talk about what the English term means and what it's going to turn into. Alright? Okay, well, let's get actually into converting some of these. Let me take this one off. Alright, here's exercise 1, and what we want to do is we want to convert this English sentence that is in quotes down here to a mathematical sentence. So I'm just going to work right along and start at the beginning and go through it and convert each set of terms, each group of terms, into what it would mean as numbers, variables, and mathematical operations. So, and we're really not even going to solve it. We're just going to convert it, and that's what I'm after right now. So, what I want to get our habit of forming is to define the variable and what it means. Alright, so this first part right here where it says a whole number has the property that when, well, that tells me I'm talking about some number that I'm gonna set equal to x. So I'm going to start by saying let x equal the number. Alright, and I want you guys to do the same thing when you start a word problem. I want you to define the variable. That's what this call is, defining the variable. Alright, so that's not too hard. So I've used this part right here. I'm done with this part right now. Alright, so I'm just going to cross it right out. And now I'm going to take the next part, and it says the square of half the number. I'm just going to take this part right here and convert it into a mathematical sentence. So, well, the square of half the number. Well, I square the number by raising it to the second power. But I want to take half of that, the square of half the number, so I have to multiply it by a half. And the way they have it worded here, they're going to square it after they half the number. So I want to make sure I put parentheses around that 1/2 x. So according to my order of operations, I'm going to half the number, and then I'm going to square it. Alright? So then I'm going to take this next part, and it says is subtracted from 5 times the number. Now this is where you got to be really careful. With subtraction, you can't just put it any which way. So when I say that the square of half the number is subtracted from, well, that means that subtraction sign goes in front because I'm taking it away from something else. Alright? And then how do I write 5 times the number? Well, 5 times the number is simply 5x. Okay? Now, we're done with this part. We're done with this part. So all I have left is we get back the number itself. Well, what that means is after I do all of this, we get back, or it equals to, the number itself, which is just x. So there you have it. I've converted the English sentence into a mathematical equation. Alright, now here is exercise 2. It says Paul has a certain amount of money. If he spends $6, then he has 1/4 of the original amount left. Alright, well, let's define our variable. Let x equal, and what is it we're looking for? He has a certain amount of money. Alright, so I'm going to just put let x equal the amount of money. Alright, very easy. Okay, so I've used this part right here. I'm going to cross that right out. So if he spends $6, well, he's starting with x dollars. And if he spends $6, no, well, we're not going to add $6. He's taking money out of his wallet. He's giving it away. Alright, so he's going to spend $6. So that means I'm going to take away $6. So now I've done this part right here. Alright, then I come into then he has. Well, that's another way of saying, well, this is equal to, alright, so I'm going to cross that out. I use that. 1/4 of the original amount left. So how do I say 1/4 of something? Well, of usually means I'm multiplying. So 1/4 of the original amount was x. So there's my equation. I've used that part as well. Okay? Alright, let me turn this one off. And let me turn the next one on. Alright, number 3. When a fraction of 57 is taken away from 57, what remains exceeds 2/3 of 57 by 4. So when a fraction of 57 is taken away from 57, well, this one's kind of different. What is it that I don't know? Well, I know what 57 is, and I know what taken away from 57, and I can write the remains exceeds by 2/3 of 57. What I don't know is the fraction of 57 you're taking away from the problem to begin with. This is what I don't know. And when you define your variable, that's what you're doing. You're writing down what you don't know. So I'm going to say let x equal the fraction of 57 I don't know. Okay, so now I'm going to use that in order to create an equation here. So when a fraction of 57 is taken away from, that means subtraction. Alright, so I'm going to take that away from 57. So here's my fraction of 57, and I'm taking it away from 57. So really, I've used all of this now. Alright, and what remains, well, that's a good way of saying, well, this equals, okay, so what remains equals, what remains exceeds 2/3 of 57. Well, how do I write this? 2/3 of 57. Well, that would just be 2/3 of means multiply. I'm going to use parentheses to say I'm multiplying 2/3 of 57. And if it exceeds it, well, that means it's bigger than 2/3 of 57 by 4. Well, how would I write being bigger by 4? Well, I would just simply add 4. And there's my English sentence turned into a mathematical equation. Alright, and guys, again, it's just practice. It's just doing these more and more and learning what English terms will convert to what mathematical terms. So here's number 4, and this one's a little different. They say the sum, so I know I'm going to be adding, of 3 consecutive integers. Well, let's take a minute and talk about what consecutive integers means. Consecutive integers is just simply integers that come right after each other, like 0, 1, 2, 3, 4. Those are consecutive integers. Consecutive means one after the other. So 1, 2, 3, 4. That's consecutive. So what they want is 3 consecutive integers. All right. Well, I have to define my variable. If these were my 3 consecutive integers, well, I have to start somewhere with something that I don't know. And let's just do this. Let's say let x equal the first integer. Okay, I'm going to abbreviate integer, int. And, well, if x was the first integer, say it was 0. Well, how would I get to the next integer? Well, if the next integer is 1, then I simply added 1 to the original. So that means x plus 1 is going to be the second integer. Okay. Well, how would I get to the third integer? Well, if the first one is x, and the next one is x plus 1, well, the third one is x plus 1, which in other words is x plus 2 is the third integer. Alright, now I'm telling you guys right now, you're going to run into this type of problem over and over in math throughout the next few years. And they're going to ask you about consecutive integers. And you always define the variables the same. It's x is the first, x plus 1 is the second, x plus 2 is the third. If you wanted to do a fourth integer, it'd be x plus 3. Alright, etc., etc. Alright, now the next problem is going to be a little different, but we'll get to that one in a minute. So they want to do the sum. Well, sum means add. So I'm going to put these in parentheses just to separate them. So here's the first, here's the second, and here's the third. I'm just summing. I'm adding those first 3 integers. And when I turn into, or when I run into this word is, well, that means equals 372. So there's my equation. Alright, first integer plus the second integer plus the third integer equals 372. Alright, so get used to doing this, because I'm telling you, it's coming up over the next few years over and over where they talk about consecutive integers. Okay? Now that one's going to be a little different than this next one. Notice now it says the sum of 3 consecutive odd integers. Alright, now this one's different. Let's say we talk about odd integers. Let's say the first one is 1. Well, the next odd integer is 3. Okay, and the next odd integer is 5, etc. Right? Well, let's say this first one is x. Well, the next one, it's not x plus 1. When I go from 1 to 3, that'd be x plus 2. And when I go from 3 to 5, I've got to add 2 more, which would be x plus 2 plus 2. So that would be really x plus 4. Alright, and etc. And the next consecutive odd integer would be x plus 6. Well, they just want 3 of them. So I'm going to come over here and I'm going to define my variables. Let x equal the first integer. And that means if I want odd, okay, x plus 2 is the second integer. And x plus 4 is the third integer. Okay, and again, just like I said in the one before, you're going to see this type of question come up over and over and over and over, alright, over the next few years. So, again, we're summing, so I'm adding. So again, I'm going to put them in parentheses so I separate them so you can see them a little better. There's the first integer, plus the second integer. I'm taking these right from up here. Alright, plus the third integer. If I add those up, it's supposed to add up to 93. So there's my equation. The sum, notice I'm adding 3 consecutive integers, here they are right here, x plus 1, x plus 2, x plus 4, is, so that's why I put my equal sign in, 93. Okay, and in the future we'll solve this, but right now we just want to be able to convert it from English to math. Alright, so there you have it, guys. Tomorrow when you come in, you'll do an assignment where I'll just have a bunch of these English sentences, and you'll need to convert them to mathematical sentences. Alright, so thanks for watching, have a good night, and we'll see you tomorrow.